Alright, this is going to be the Unit 2, Part 1 review. To start with, we're finding slope. To find the slope between 2 points, we're going to label our points x sub 1, y sub 1, x sub 2, y sub 2, and we'll plug them into the slope formula. So on top of this, on the top of the slope formula, we have y sub 2, that's negative 5, minus a negative 4, over negative 3 minus 3. Negative 4 minus a negative, negative 5 minus a negative 4 is the same as negative 5 plus negative 4, so that's negative 1 on top. And then on the bottom, negative 3 minus 3 is negative 6. A negative divided by a negative is a positive, so our final answer here for the slope is 1/6. Positive 1/6. If a fraction has a negative on top and on bottom, then it's positive. For the second one, same idea, label your points, and we'll substitute into the slope formula. On top we should have 7 minus 2. On the bottom, negative 3 minus a negative 3. Minus a negative, we'll change the plus to positive. So on the top, 7 minus 2 is 5. On the bottom, negative 3 plus 3 is 0. If you put this in your calculator, you should get some type of an error. We can't divide by 0, that's undefined. Or sometimes we may say no slope. Still finding slope, we'll label our points, and we'll substitute into the slope formula. On the top, 2 minus 2 is 0. On the bottom, negative 5 minus negative 5 minus 4 is negative 9. 0 divided by negative 9 is 0. Same idea on 4. Label your points, plug them into the slope formula. 1 minus a negative 2 on top, that'll become 3, and then negative 3 minus a negative 1, negative 3 plus 1 is negative 2. So we get 3 over negative 2. You just have one negative sign, so the fraction is negative. So our slope here is negative 3/2. Average rate of change is the same as slope. So we need to locate our points. We've got 4 o'clock in the afternoon, temperature is 80 degrees. And then 8 o'clock that evening, it's 60 degrees. And so we'll label our points and substitute into the slope formula. So on the top we should have 60 minus 80. On the bottom, 8 minus 4. And so we get negative 20 over 4. Or negative 5. Now in our final answer here we want to put units, so that those top numbers were degrees, and the bottom number was hours. So we get negative 5 degrees per hour for the average rate of change. Here we're looking at a little bit different format, but we're still finding rate of change. This time we're looking from 2000. So we've got the points there. So 2000, 3,728. And then 2010, population was 4,524. So that's our ordered pairs. We'll label them and substitute into the slope formula. So after you subtract, you should have 796 on top, 10 on the bottom. Divide that and we get 79.6. That's people per year. or you could say population per year. Alright, for slope, we need, this time we have a line, so we're going to find 2 points where it clearly hits the grid marks, and there are some, you've got a couple of options here, but these are the two I'm going to look at. So if I start at 2, we go down 1, so my slope, my rise is -1, we go to the right 4. So I have a slope of -1/4. The y-intercept, that's the place where your line intersects the y-axis, that we could say that the b is 2, or you could say the ordered pair is 0, 2. And then number 9, we're putting all this together. So on 9 we need to write, instead of m, we're going to put that slope, -1/4 x, plus the b, which is 2. So that's the equation for that line in slope-intercept form. Here we're doing all of that, but we don't have kind of the scaffolding questions. So we've got to figure out our y-intercept and our slope. So you can look at it and see that the y-intercept on this one is -2. If we do rise or run between these 2 points, we go up 1, 2, 3. And we go over 1, 3 divided by 1 gives us 3 for the slope. So y equals mx plus b, y equals 3x minus 2, you could say plus a -2. It's the slope-intercept form of the equation of that line. Here we have the equation, it's in slope-intercept. So our slope is the coefficient on the x, 3/4, and the y-intercept is -2. So think of that y-intercept as your beginning point. So we're going to put a point at -2, then we're going to go up 3 to the right 4 from that point. You can also go down 3 to the left 4, find another point, and now we'll connect those using a straight line. So we have the line graphed. 12, same idea. Slope is -3, -3/1. Since we're graphing, we want it as a fraction. Y-intercept's 1, so start at 1 on the y-axis, then go down 3 to the right 1. You can also go up 3 to the left 1, and then we'll connect those. A little different when you only have one variable. We're going to find -1 on the x-axis. And then when you only have one variable, it's either going to be vertical or horizontal. In this case, it's going to be vertical. If it's x equal to a number, it's vertical. If it's y equal to a number, it's horizontal. If you forget how to do it that way, another way you could think through it is doing an XY chart. The x values are -1 no matter what. And then if you pick different y values, so we'd have -1, 0, we'd have -1, 1, -1, 2, and so on. (14), we only see y, so let's find the y value of 2. We'll go to the y-axis and find 2. And then if it's only y, then it's a horizontal line. Again, if you forget that, you can fill in the 2's for y. Y is equal to 2 every time. And then pick whatever you want for x. Just pick ones that'll be on this grid. So we have 0, 2, 1, 2, and 2, 2. So you can see that horizontal line forming. Here it says the cost of a single scoop ice cream is $2. So that's our starting point, or our B. So we're going to start at 2. Each extra scoop of ice cream costs an additional $1.50. So that's our slope. Now the slope of $1.50 is the same as 3 over 2. So we're starting at 2. Now if you look at your graphs, A starts at 0, B starts at 2, but it's on the x-axis, so wrong axis. C and D are still in the running. They both start at 2. Which one increases $1.50 for every 1 scoop? So your choice should be C. According to D's graph, no matter what, it would cost just $2, no matter how many scoops. So C is the correct graph. Alright, Jack walks in a straight line at a constant rate of 2 feet per second for 3 seconds. So this first movement, 2 feet per second for 3 seconds, means 6 feet. Actually, I'll do time first. Time of 3 seconds and 6 feet. So if we start at 0, 0, alright, so after 0, 0, put a point at 3, 6. Then he stopped for 2 seconds. When he stopped, the distance does not change. So our next movement is 2 seconds, no feet. So this forms a horizontal line segment. And so we should be at 5, 6. Next, he walks farther away from the starting point at a rate of 3 feet per second 1 feet per second for 3 seconds. So 3 seconds have passed, 1 feet per second, so that's 3 feet farther away from the starting point. So now we're at 8, 9. And then finally he returns at a constant rate of 3 feet per second. And so he's 9 feet away, so it's going to take him 3 seconds to get back. Again, 3 feet per second. We're not told the time, but 9 feet away, that's going to use up 3 seconds. If you forget how to do that, you can do distance equals rate times time. We know the distance is 9 because he's 9 feet away and he's going all the way back to the starting point. The rate is 3, so you could divide that by 3 and see that the time has to be 3 seconds. This one we already have the graph. We're just looking for the portion where he's stopped. So horizontal line segment is where he stopped. So it's this portion of the graph that we're looking at. So the times for that are 3 to 5 seconds. I have it labeled as X there. Probably should have labeled it T for time. So you could have either that or this. But notice it's 3 to 5 seconds that he stopped. And then 18, if his first movement was to the right, when was he moving to the left? So his first movement to the right took him away from the starting point. So it's this portion here where he's going back towards the starting point. And so that would be from 5 to 6 seconds. Again, based on the way I have it labeled, you might have X or you might have T, just knowing that T often represents time. Hope you've enjoyed this video.